Hello students. So today we will be discussing a very important topic from a very important chapter. And the chapter is chemical bonding and we will be discussing VBT, Valence Bond Theory and Hybridisation. So before starting the topic, let me ask you, why does the bond formation takes place? Why do atoms combine? Yes, to attain stability, right? So, to attain the stability, these chemical bondings are taking place. But now, how does this bond formation takes place? Yes, that is what we are discussing through VBT, Valence Bond Theory. Okay, now let's discuss about Valence Bond Theory. So, let's consider the example of hydrogen. So, there are two hydrogen atoms. So, there will be nucleus. So, this is the nucleus of one hydrogen atom and this is for another hydrogen atom. And of course, there is one electron in the outermost shell, right? So, see, what all are the possible forces here? See, we know this electron will be attracting with this nucleus, right? So, there will be an attractive force will be there between these. And similarly, between this nucleus and with this electron, we know positive and negative will attracts. That only. This nucleus attract the electron of this hydrogen atom and this nucleus attract the electron of this hydrogen atom. Yes, so two attractive forces are there. So only attractive forces? No, right? There is repulsive forces as well. See, same charges repel each other. So this negative charge and this negative charge, that is this electron and this electron, they will repel each other. They are of the same charge. Similarly, this nucleus, which is positive charge, and there will be a repulsion. So, there are two types of forces are there, attractive force and repulsive forces. Now, see, consider two hydrogen atoms are there, right? So, when these hydrogen atoms are coming closer, that is, they are coming closer, which means initially attractive force is dominating there. So, since they are coming closer and closer, attractive forces are dominating. That's why they are attracting. They are coming closer, right? And at a particular time, this attractive force and repulsive force will become equal. So, let's check its energy internuclear distance graph. See, these are two hydrogen atoms as I discussed earlier. So, initially that attractive force dominates. So, they are coming closer. See, so you can see, and when you can see the decrease in its energy, right? So, and see, at this particular point, you can see those hydrogen atoms overlapped. So, and this point is where the attractive force and repulsive forces become equal. And let's see the energy, and that is the point where it is showing minimum energy. And at this point is actually that bond formation takes place. So, students, actually at this minimum energy point, what is happening? Let's see. See, let's take the example of hydrogen only. We know this electron in hydrogen atom, where does it locate? In 1s orbital, right? And for this also 1s orbital only. So actually what is happening at this point? When this attractive force and repulsive forces are equal, this electron is inside the 1s orbital and here as well, right? So when the energies are equal, these orbitals are overlapping. And yes, So the bond formation takes place by the overlapping of atomic orbitals. So let's discuss this valence bond theory for CH4 molecule. So CH4, let's take this example. So what is the electronic configuration for carbon? Yes, 1s2, 2s2, 2p2, right? So let's draw the energy box diagram. Yes, there are 2 electrons in the 1s orbital and again 2 electrons in 2s and in 2p 2 electrons, right? So this is 1s, 2s, 2p. See, I need to form CH4. So there should be 4 unpaired electrons should be there. But see, here how many unpaired electrons are there? Only 2, right? So what will do? See, that is why excitation will happen. So this is the ground state configuration of carbon. Now the electron from 2s will be excited to 2p. So now let's draw that. So 1s, which is not involved in, it's there. Now in 2s, only 1 electron is there. Now 2p, yes, 3 electrons. Now see, now there is 1, 2, 3, 4. 4 unpaired electrons are there. So we can form 4 bonds, right? Okay. And this is known as excited state of carbon. Yes. So there comes hydrogen. So in case of hydrogen, where does the electron locate? In 1s orbital. So there are 4 hydrogen atoms are there. So let me draw here. So this is first hydrogen's 1s orbital. And there are 3 more. So in each 1s orbital, 1 electrons are there, 4 hydrogens. Now what happens? According to VBT, we have discussed these atomic orbitals will overlap, right? So the s orbital of hydrogen, s orbital of carbon will overlap with the s orbital of carbon will overlap with the s orbital of hydrogen, and this p orbital will overlap with hydrogen, then this, right? So here 3 bonds are formed by the overlapping between 1s orbital of hydrogen with the 2p orbitals of carbon. Let me draw that. See, CH4. We know it is tetrahedral, right? CH4. See, out of these 4 bonds, let's consider these 3 bonds are formed by the overlapping of PS, that is p orbital of carbon with s orbital of hydrogen, and same here as well, here as well. Now what about this? This is formed by the s orbital of carbon with s orbital of hydrogen, right? But see, there is a problem. See, if one is formed through SS overlapping and the other 3 are SP overlapping, which means these 3 bonds should be, or bond length, it should be different from this one, right? That is, these 3 will be having, let's say X, bond length is X, and this should be different, it might be Y. But in actually, it's not so. Actually, in CH4 molecule, all the 4 bond lengths are equal. So, see, before overlapping, something is happening there. And what is that? Yes, that is hybridization. So let's discuss that now. See, so I am removing all these. Okay, they are not overlapping. Instead of overlapping or before overlapping, see this 1s and this 2p, sorry, this 2s and this 2p. These three will undergo hybridization. Now, what is hybridization? Yes, it is intermixing of atomic orbitals, not overlapping. It's intermixing. That is, this s orbital and these three p orbitals will undergo intermixing. So, what is hybridization? So, hybridization is intermixing of atomic orbitals. Yes. So, here before overlapping, the carbon, its 2s and these three 2p orbitals will undergo hybridization. They will intermix and intermixes to form, see, one s is there, right, s, and 3p, that is sp3 hybridized orbitals will be formed. So 1, 2, 3, 4. 4 sp3 hybridized orbitals will be formed. Yes, now we can explain, right? Now the surrounding atom, hydrogen will come. That is, so 1s orbital of hydrogen, there is one electron, and there are three other hydrogen atoms, and each contains 1 electrons. Now see, these sp3 hybridized orbitals, it will overlap with the 1s orbital of hydrogen. Again same, sp3 hybridized orbitals will overlap, and here as well, here as well. Now let's redraw the structure of CH4. So carbon, hydrogen. See, so the first bond is formed by the overlapping of sp3 hybridized orbital of carbon with the s orbital of hydrogen, and same for the next overlapping also, sp3 with s, same sp3 with s, sp3 with s. Yes, now the problem is sorted, right? Now all the overlapping, all the bonds are formed by the s with sp3 overlapping, right? So all the bond lengths are equal. Yeah, so we have seen in CH4, the carbon is undergone sp3 hybridization, right? So is there only sp3 hybridization? No. See, in some cases, in some molecules, s will overlap with one p orbital, and which will be forming sp hybridization, and similarly one s orbital overlap with two p orbitals can form sp2. Similarly, s with 3 p orbitals will be forming sp3. So only s and p? No, d also. Similarly, there is sp3d is there, that is 1s, 3 p orbitals and 1 d orbitals will undergo hybridization. So then similarly sp3d2 is there and d2sp3 is there. Okay, so these are the different types of hybridizations possible. sp, sp2, sp3, sp3d, sp3d2 and d2sp3. Okay, so we have find out the hybridization. So what is the purpose of it? See, based on the hybridization, we can predict the geometry of the molecule. See, you can see, I have drawn some tetrahedral shape for CH4, right? How how I know it's tetrahedral? Based on this hybridization. See, if the hybridization is sp, then see, its geometry will be linear. That is, it will be like this, linear shape. And if it is sp2, it will be trigonal planar. Trigonal planar. B, B, B. That is 3 corners of a triangle. Now, sp3, yes, it is tetrahedral, right? Tetrahedral. This is tetrahedral geometry. Now, sp3d, which is trigonal bipyramidal. Trigonal bipyramidal. Yeah, it will be like this. There will be a triangle like this, and above the plane one B will be there, and below the plane as well. That is, the triangle will be here, and above the plane one B and below the plane. That is what trigonal bipyramidal. And sp3d2, which is octahedral. That is central A and B, 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 B as a square, and there will be above the plane one B and below the plane as well. This is what octahedral shape. And same for D2 sp3 also, it is octahedral only. Now see, this is how we identify the geometry, and from the geometry we can find out the bond angles as well, right? See, for linear, we know it is 180, and for sp2 trigonal planar, it will be 120 degree. Now sp3 tetrahedral, and its bond angle is 109 degree 28 minutes. So what about octahedral? It is 90 degree. Here all the bond angles are 90 degree. So is it clear? So this is what valence bond theory and hybridization. So at the minimum energy point, these atomic orbitals overlapping, right? So before that, hybridization takes place. Now see, let me ask you, so is there any trick to find out the hybridization, or do we have to draw the box diagrams and everything? For NEET, JEE exam, you have that much time? No, right? So there is a simple trick to find out the hybridization. Let's take the same example, CH4. So what is it? How many valence electrons are there in carbon? There are 1, 2, 3, 4 valence electrons, right? So how many bonds we need to form? 4. So each electron will form bond with the hydrogen like this. Now here how many bond pairs are there? 1, 2, 3, 4. 4 bond pair. And is there any lone pair? No, right? That is 0 lone pair. And this number, bond pair plus lone pair, that is known as steric number. So we have to find out the steric number. So here the steric number is 4, right? So if the steric number is 4, it is sp3. So let's see, steric number and corresponding hybridization. See, if the steric number, that is, what is steric number? Number of bond pair plus number of lone pair. If it is 2, it will be sp, actually it is 1 plus 1, 2. And if it is 3, then it will be sp2, 2 plus 1, 3. If it is 4, sp3, and 5, then sp3d, and 6, then sp3d2, or it can be d2sp3 as well, right? Now, so you have to find out the steric number only for your NEET JEE exams. Now we'll discuss one more example for water. What will be the hybridization? Let's just try. Yes. See, here the central atom is oxygen. What is how many valence electrons are there? 6. Its electronic configuration is 2, 6. Right? So there are 6 valence electrons are there. 1, 2, 3, 4, 5, 6. And out of these 6, 2 will be bonded with hydrogen. H. Now, how many electrons are there remaining? 1, 2, 3, 4. That is 1, 2. 2 lone pairs are there. So, in this case, the steric number will be, there is 2 bond pairs plus 2 lone pairs. That is total 4. Let's see. Yes, if the steric number is 4, the hybridization is sp3. That much simple. So, dear students, I hope this valence bond theory and hybridization is very clear for you. So, see, the time management is very important for your entrance exams, right? So, see, I can find out the hybridization in 2 different ways, right? So, but which one is the smarter way? Of course, the second one, right? So, be smart and choose the way or choose the step which is easier for you and which will take less time, which is very important. Okay, so that's all, and all the best for your exams. Thank you.